Hello to all. Welcome to this next session of training on remote sensing and GIS in using QGIS software. In this session, we are going to talk about multi-criteria overlay analysis in QGIS. And to understand this topic, we will do a small exercise on site suitability mapping for Goa for any type of structure. Hello, my name is Sukanjan, and I'm working as a scientist C in National Institute of Hydrology. So the learning objective of this particular session is that by the end of this session, we will be able to learn about understand the basic principles of multi-criteria spatial analysis. To prepare and rasterize the vector data for overlay, compute the distance and reclassify the raster layers, combine criteria using weighted overlay, and export and create and exporting a site suitability map that can be directly utilized in any type of reports. When we talk about multi criteria overlay analysis, it is defined as a technique to evaluate and combine multiple spatial criteria to identify the most suitable area for a specific purpose. For example, if you want to build any kind of structure, for example, school. So, in order to establish a school building, you need to focus that which is the location will be more appropriate for you as an investor to create the location to create the school building. So, of course, it should not be far from the city. One thing is that. Second, it should be close by the roads. Third, there should not be industrial area in nearby vicinity of the school building, and there may be another criteria that kept into the mind. Maybe if you are working in the government department, it is your duty to identify the waste disposal area in your city. So for that purpose, GIS or the spatial analysis comes into the picture, because GIS will tell you that the most suitable site not only basis of one or two criteria but based on many multiple criteria, like as I told you, like distance to the industrial area, distance to the road, distance to the city center, and other things. So all of these information into the raster or the vector or the GIS format can bring into in any of the GIS platform, and we can perform this multi-criteria overlay analysis to identify that which is the most suitable site to build our infrastructure. And this thing can be done in the various sectors. As I told you that site suitability doesn't have to be specific only for civil engineer or water resource person. It can be for any domain, like landfill location for urban planning, groundwater recharge zone, hazard and vulnerability mapping, natural resource presentation, and of course in these days now, for the finance and other domain, these kind of structures or these kind of application are in the use. Now, I think you have already covered the overlay analysis using the vector data. But in this exercise, we are going to talk about overlay analysis using the raster data. So first, we have to understand what is the difference between the raster and the vector. I think that you have already covered those session. That raster is nothing but the information in the pixel formats, and vector information is in the geometry format, either point, line, or polygon. Okay, so as a data type, raster overlay, it has a continuous grid cells, but in the vector overlay it has a discrete points, line, and polygons. The computation, the raster overlay, it is we compute the things on the pixel basis, which is faster for the large areas. But in when we are doing overlay analysis for any larger area, vector overlay can be slower, because here the geometry is defined, and for the each geometry various vast amount of data set is being gathered. So that's why functionality of this vector analysis can be slow. We can combine multiple layers in the raster. As I told you that if it is the fast way to perform overlay analysis, so multiple layer can be utilized in the raster domain. But in the vector, it can be complex, and it also requires some attribute information and some multiple things that can be that has to be done for pre-processing of any data sets. Accuracy of boundary is lower because it's depend on the resolution. For example, if you want to create overlay analysis for a city area, so we need to gather the raster layer at the city level, a very high spatial resolution. But In the vector, the accuracy of the boundaries will be high because we will be getting the exact geometry of that particular area. The raster overlay analysis best suitable for suitability analysis, distance mapping, and vector overlay analysis best for the overlay of administrative zone and categorical zone. But the most important difference which I found, and I want to tell you that output. In the raster overlay, the output will be in the ranking method. That means you will, at the end of this session, we will be able we will be able to rank locations based on our marking system. So you may find best suitable, least suitable, medial suitable. But in the vector overlay, you will get only two output, either suitable or not suitable. So these type of things and difference create the difference between the overlay analysis using the vector data and overlay analysis in the raster data set. So in this particular exercise, we are going to talk about overlay analysis using the raster data set. So first of all, we will gather the raw layers. In this exercise, we will not be utilizing any of the predefined data sets. I will explain you how to download some specific data directly from the scratch, from the open source domain. Then we will convert the data from vector to raster, because it might be possible that some of the data set may be provided to you in the vector format. So the advantage of raster thing is QGIS is that it is very easy to convert the any type of vector data into the raster data. Then we will perform the proximity analysis using in which we will get the distance. For example, if you want to identify a single pixel which have a distance of like 5,000 kilometers from the road. So using the proximity analysis, we will identify the distance. Then we will reclassify as per our assigned score. Then we will overlay in different layers, and the final map, that is the suitability result, will be on our screen. So the input data set that we are going to use for this exercise, state boundary, which will be a polygon, then roads, which will be a line, river and water bodies. So river and water bodies can be line and the polygon. For example, the river, which is a very which is not have a large cross section, will be represented in the line, but the large rivers or the river with a wider bed, or the lakes, are going to be represented in polygon. Protected areas, we are going to gather the forest boundary, so that we can apply a certain condition that our suitability site should not be into the protected area or the forest area. And the optional layer, like if you want to include like elevation, land use, other things can be included. Okay, so in this case we are going to use these four things, that is road, river and protected areas. And all of these are the typical source of these kind of data sets. For example, state boundary, survey of India is the authentic organization to provide the data sets. Road, you can gather from the OpenStreetMap. River and water bodies, Hydroshat is a good website which provide you the water bodies of whole world. Protected areas can be gathered from the forest department or WDPA or WII also. And some other layer, if you want to use, you can extract from the other of the sources. But in this case, as I told you that we are going to talk about this exercise, we will gather the data from the scratch, and we are going to gather the data from single source, that is OpenStreetMaps. In this particular example, we are going to identify any suitable site which is closer to the road, farther from the river, and away from the protected areas. So we will decide a certain criteria that if the road is between 0 to 2 kilometer, it is better. If the distance from the water body is less greater than 1 kilometer, it is better. And if it is not in the protected areas, it is a very suitable condition. So we will going to apply these three conditions on our raster datasets. So first of all, we will prepare our datasets. The most important thing in any type of any type of exercise in QGIS is the reprojection of datasets. So we are going to reproject our dataset into an UTM zone. So currently we are going to talk about Goa. So I will tell you how to identify the UTM zone of Goa or any specific area. Then we'll click to a state boundary. Then we'll verify the attribute table and geometry. So the consistent projection and extent are the crucial for accuracy overlay analysis. Suppose if your area, for example, if you have a road layer maybe of this boundary extent, okay, but your water body is only having the boundary extent of this, okay, so this might result not the accurate data for this particular region. For that purpose, we need to make sure that all our layers and should share the common projection system and should share the common extent boundary. Then we will first of all we gather the data. Second, we will rasterize the data. That means a conversion from vector to raster. I will tell you that how to convert the vector data into raster and how we should burn our cell value with the particular values. Then we will apply the proximity analysis, raster distance. The output of this raster will be output of this tool will be a raster, which will tell you the pixel value will tell that how much is the distance from the required parameters. So we will be using the maximum distance of 5000. We will going to explore later. Then we will reclassify based on our, as I told you previously, that we need to set up certain rules that if it is closer to the road it is good chance. So that's why if it is a distance of less than 1 kilometer, then it is highly suitable. So we will provide a maximum marks for that. And if it is greater than 2 kilometer, we will provide lower marks. That means 10. And if it is between 1 and 2, we will provide a moderate marks. So similar case, we will going to apply for the roads also. For example, we don't want our suitable site to be nearby the water body. So we will going to reverse this marking equation, like lower marks if the water body is closer. And we will define the weightages. For example, if you want to put more weightage for the roads, we can provide certain factor. Like in this case, road has a 60% of weightage and water will have a 40% of weightage. And the combined criteria based on their relative importance, it is up to the user which factor they want to use based on their judgment. Then finally, we will use the raster calculator to, and of course, the one of the criteria that we are going to talk about, the masking the protected areas. So using the road layer and the water body, we will identify the which is the best or not best. But we have to eliminate the area which are lying in the protected areas or any other in your case. So we are going to eliminate the areas also. And finally, we are going to gather the map, which will be a classified map, in which there will be certain classes like low, medium, high suitable, and we will try to visualize in a more informative manner. And we can export, always export these kind of maps into the PDF or PNG with adding proper frame, title, legend, etc. So now for this purpose, first of all, we will gather the data set. In order to gather the data set, there is a website known as GeoFabric. You need to search for GeoFabric download. It is a website through which OpenStreetMap dataset can be downloaded in a very easy manner for whole of the world. Okay, so you need to open this geofabric.de data download, and if you go scroll to the down, you can read about this dataset, how they have gathered the dataset, and so you need to go to this website, our download server at this particular site, download.geofabric.de. If you go downwards, you can see that the data sets are have been defined in certain regions. For example, we want to extract for the Asia region. As you can see that in the right hand side there is a map. So when we scroll, move our mouse from Africa to Asia, there is a red sign which will tell the user that this area belong to this red zone. So I'll just click on Asia, and in the Asia you will find multiple subregions. So I'm interested in India. So let's take India. And in India, the region is divided into uh, certain zones like Central Zone, Eastern Zone, Northeastern Zone. northern zone, southern. So we are going to explore western zone because we are focusing on the Goa, and Goa is lying in the western zone. So I'll just click on that. And as you can see, this is the area for which this dataset can be downloaded. So either you can download the zip file or the PBF file. We are going to download the zip file. You can find over here like common used formats. The second format is Western Zone Latest Free .shp.zip. I'll just click on this. It may take certain amount of time because it is approximately 500 MB. So you can see that uh, it provides certain data into the easily compatible shapefile format. So I have already downloaded this zip file. So we need to first of all extract the zip file. Meanwhile, I'll just open the QGIS. So currently I'm using QGIS 3.40.7. I'll just open this and we will extract this file. Right click on this, extract all. So in order to understand about this data set, you can go to their website and try to understand that how they have created the data set and what are the things included in this kind of data. And we will be exploring this data set into the QGIS as well. So this is the folder. As you can see that multiple files are there and most of the things are in the shapefile format. And there is a README file. You can always explore this to understand what kind of data set. As the name suggests, if I just apply the filter of .shp, so I can see that there are over 18 shapefiles. As the name suggests, it is a GIS OSM. OSM means OpenStreetMap, buildings, land use, natural free, um, places A. Here, the A difference suggests the area, and the L, the free means line file or the other file also. So I think the QGIS is opening, so we need to wait for that. Okay, the QGIS is open. So we will go to the project, new project, and we will open our layers. I'll just copy the path, go to the layer, add layer. As we know that all the files in this folder is the shape file, that means the vector. So we will click on add vector layer. We will make sure that this should be on the file. We'll click on three dot. I will paste my path and I'll just open the folder. Now there are multiple files. I'll just apply the filter of ISRI. So I'll just go to the all file, type E and search for ISRI shape files. Now I can see that only the shape files are come over here. So I'll just select all the files to understand what kind of data set is this. And for our exercises, what kind of data set that we will be needing. Okay. So I'll just uncheck all. So in order to uncheck all, I'll just click on this I button and click on hide all layer and let's see one by one. So as the name suggests, it is a water base. Okay. In order to cross check, we will open a Google map or a base map or a Google map. So I'll just go to the HCM GIS, go to the base map and open this Google map. I'll just make this thing on the lower side. So if I just zoom into this particular, so I can see that yes, this particular line which I've just selected is nothing but the water body. So we will be needing this line. Then we have OSM water A. So it means the water in the polygon. As I told you that sometimes water body which is a broader section is going to be denoted into the polygon. So we will going to be need this as well. Then this is a transport. So this is just a point. So we don't need as of now. Then this is a transport. This is also uh, we can always open the attribute table to understand what kind of data set is there. Okay, so these are the stations file of the transportation, like airport, bus station, ferry, etc. So this thing can be for utilizable in any other case. For example, if you want to identify, if you want to open a hotel which is nearby the airport, so you can utilize this data set and follow the methodology that we are adopting in this exercise. So but currently we don't know, we don't need this. So I'll just remove these two lines, two things. Then we have traffic points dataset we will not be needing. Then there is a traffic A. Let's see what this data suggests. Okay, so let's open the attribute table and understand. So yes, it has a data set related to some trafficking like parking, fuel station, okay, dam, peer. Okay, so you can extract these kind of data set, and which it can also be utilizable in certain kinds of analysis, but in current case we are not going to use this. So I'll just remove this also. Now we have roads. Yes, the road layer is nothing but the line file of all the roads. Okay, currently we are not going to the not focusing on the accuracy of the dataset, because as I told you, it's an open source dataset, so the accuracy might not be that much accurate. If you're working for a government department, it is an utmost priority that you should gather data from the authentic source. We're just going to talk about the methodology. So yes, we will going to be use this OSM routes. We're not going to use the railway, and this let's see. I'll just remove the railways. Then this is POIS. Okay, let's just open this guest house viewpoint. Okay, these are also points you can use in other kinds of exercise. Post office, hospital, we are not going to use this. We are not going to use POIS other also. This is POFW. That means I think this is the place of worship. I'll just open the attribute table. Yes, this is the name locations of temple, church, gurudwara, mosque, etc. So we are not going to use this POFW. Then we have places. I don't think so. This is also necessary in this our case. So I'll just remove this also. Now natural also we not be needed. The only thing that is remaining for our exercise is the protected areas. So the protected areas come in the land use. So if you open the attribute table of the land use, we will find that there are certain type of like scrub area, forest area, military area, residential area. Okay, so you can extract multiple boundary out of this, but currently I'm going to focus in the only in the forest area, and building also we will going to remove. So these are the four layers which we are going to use for our analysis. Okay. Now, in the land use, there are multiple classes. If you just go to the layer styling panel, and in this, we will select the land use, and in the symbology, we will click on categorize, and the category we want to build as a F class, classify. So you can see that there are multiple colors are there for the multiple classes. Okay, but we are focusing for the forest area. So what we will do, we will filter out only the forest area. There is two way to do that. One is, as I told you yesterday, sorry, in the previous session, that either you can click on this, click on Control F, okay, and click on F class is equal to, you click all and forest. F class is equal to forest. So now only forest boundary will be visible over here. Okay, you can use this as a temporary layer, or you can select always. I'll just remove the filter first. You can always use this select by expression. I'll just click on this select by expression. Okay, and or you can select use the select features by value, which is much easier. F class, should be forest. As you type, all the name will be displayed over here. Select feature. Okay, so it's showing that 6949 feature has been selected. You can always export this particular layer, save selected feature to a new protected region. But in this case, what I'm going to do, I'm just going to uh, click Control F class, because I found this is one of the easy method without creating another source of layer. Okay, so now, as I told you that as per our slide, we will going to use these criteria to identify the best suitable sites. Now, the first thing that we need to do is to clip our boundary for the Goa region and reproject. Okay, that means confirming that the extent and the projection of all the layers will be the same. So, for that purpose, first of all, we will open the state boundary of India specifically for Goa. So, I'll just go to the layer, add layer, add vector layer. In the previous session, we have provided the India state updated boundary. Okay, so if I just, you can cross check this. This is for the Goa, either by unchecking the Google Map or base map, or you just go to the layer styling panel. In the layer styling panel, we will go to the label, and in the label, we will go to single label and the state name. So yes, this is the Goa. You can filter out using Control F. State is equal to Goa. Okay. So now we need to clip all the layers with this specific Goa boundary. I'll just drop it over here and make sure the extent will be the same and the projection system is. So first of all, we will need to convert the projection system. So I'll just go to the vector, data management tools, reproject layer. Let's just see that if the clip will be in the clip function. Okay, yes, for the reprojection, we need to go to the vector research tool, or sorry, data management tool, reproject. We will first of all select the land use. Okay, the target CRS. Let's see the UTM zone. In order to identify the UTM zone of your own area, either you can simply Google. So if you go, just go to the Google and search for Goa region UTM zone. So in nowadays, AI will able to answer your query in just a few seconds. So you can see that Goa is lying in the 43 north. You can cross validate this answer with some maps. For example, this is the UTM zone map of India. If you just open this particular map, you will find that yes, this particular from this section to this section, sorry, this to this, it's a UTM 42, but the Goa is lying in this section. That means UTM 43 north. So we are sure that our area lies in the 43 north. So I'll just go to this particular button and search for 43N. And after searching for 43N, you will find multiple 43 north zone over here. As you can see that it is a Kalyanpur 1962 WGS 72, but we need to select WGS 84. It is most prominently used UTM zone. And when we click 43 north zone, the red line is suggesting the area. So if you're just going to zoom this area, we can clearly have an idea that yes, Goa is lying in this particular red zone. So we will select this and back. So this is our original layer, that is land use, and this is our 43 north zone. And we are going to save this file to a permanent layer. Why? Because in this kind of exercise where multiple processes are there, it is a very common practice to, it's a good practice to save this data set on the regular interval. So I'll just go to the QGIS, I'll just make a new folder, overlay output. Okay, so first of all we are saving land use or the protected region, or I can say protected region, okay, in UTM. Either you can save in the geo package format, but currently I'm going to save into the shapefile format. Save. Run. You can see that UTM protected is there. Now we are going to do this similar kind of exercise for waterways, water, and roads as well. So we'll just go to the research tool, vector, data management tool, reproject. Next we will select the roads, UTM 43, save to file, roads, save, run. It may take some time depending on the amount of data set that we are computing. You can fast forward this video. So yes, our roads is also converted. Without closing this window, I'll just select water area. Let's just rename this water underscore A. Then in the last, we will select water base, water line. Now we have converted all of these data set. Now let's convert the state boundary also, so that the clipping will not be occur with the error. So I'll just use Goa BND, means boundary underscore UTM. Uh, Okay. So now all the layers are converted into the just converted into the UTM protected zone, Goa boundary, water line, water area, and roads. Now we will going to extract this boundary, or I can say the clip this boundary, clip this layer with with our Goa boundary. So for that purpose, you can use or simply what we can do now this thing can be over, either you can just go to the uh, processing toolbox and use clip. clip vector overlay, because currently this is the vector boundary. Okay, in the clip you can provide the input layer like protected region, and the overlay boundary will be the Goa BND. Okay, you can do this one by one, or you can skip this step and you can clip with this particular state boundary in our next step. So the next step that we are going to perform is the conversion from vector data to raster data set. And for that purpose, there is a tool known as vector rasterize. So I'll just go to the raster, conversion, vector to raster. Or you can always search for this processing toolbox, rasterize. Okay, vector to raster. So now in vector to raster, first of all, we will select any of the layer. For example, just I'll take water line. Okay, now in order to convert the vector to raster, so currently we are not focusing on converting the values of this water body. We're just going to identify that where there is a vector boundary, there is a shape file is there, the line is there, make this pixel as a 0 or 1, otherwise make it 0. So we're going to use this, fix a value to 1, 1. Okay, then afterwards we are going to use this particular outputs raster size units as a geo-referenced unit, because we have already pre-projected our data set. So all the units are going to be now in the meters. So now next step is the to provide the spatial resolution of the output raster. At it depends on you, this area of extent and the amount of data set and the amount of accuracy you are using. So currently we are just provide the maybe 30 meter of pixels. Okay, I think this is very much lower. Okay, I just said 20 meter of pixel. So 20 by 20 meter. Okay, next thing, that is the output extent. So if we skip this clipping, we can provide the output extent, and the output extent we can provide, just go to the calculate from the layer, just go to this button, calculate from the layer, and provide Goa BND underscore UTM. So as you can see this, the easting northing of the extent will be displayed over here. Next thing, the assigning the no data will be 0. Then there is a thing in the advanced parameter, we need to provide the high compression, because the output of the raster may be very high much in volume. So in order to compress, what we will do, we'll just go to the advanced parameters, go to the profile and click on high compression. Okay, this will reduce the output raster size. And finally we will provide the path of this raster, saved to a file. So currently we are converting, I think, water line. So make sure that you need to provide a proper nomenclature so that you won't be get confused. So I'll just provide water, or I can say water line. Save, run. So I'll just first, not closing this thing, I'll just first of all removing all the unwanted layer. And you can see this, we got the raster. And if you just go to the zoom into this particular feature, and I'll just open the water line above this. So this is the water line, and water line now converted into a continuous raster. And at the same time, initially the water line was for the whole east western zone, but now after clipping, we get the water line in the pixel format for the Goa region only. You can see that this is the Goa region, and apart from the Goa region, the things is not converted. Okay, so we skip one step and we perform the clipping in the same function. Now we will going to do the similar thing for the other layers also. For example, I just go to the above, and instead of water line we will select water area UTM. Make sure that you selected UTM. Everything will be remain as it is. That means fixed value to 1 is 1. Georeference unit is we select the output unit as georeference unit. Then spatial resolution is 20 by 20, and we will select the extent and the high compression, and we just need to change the output path. Otherwise it will overwrite water area. Run. The next thing, we're going to convert now water area roads. Everything will be remain as it is, and we click run. Now the lastly we are going to convert the protected area or the forest area. So I go to the protected UTM, and everything remain as it is, and just click raster protected. Or I think I provided the forest is protected region. Run. So I'll just close this line and let's see what kind of output we are getting. So we first of all we got the raster water line, in which raster pixel value, where is the pixel value is 1. uh, as you can, if you just click on this identify tool where the pixel value is 1, there is a water body, and where the pixel value is no data, that means there is no water body. And similar goes for raster protected. If this is pixel value is 1, I just select this raster protected. If the pixel value is 1, that means there is no water body or no protected region. If the pixel value is no data, there is a protected region. Similar for the raster roads, and similarly for the water area. Okay, you can always cross check by using the Google map or any other base map. Okay, now next thing that we do is to fill this no data to the zero value, as we need to compute these kind of layers. So we will be using filling this raster value with the sorry, the no data value with the zero value. Okay, so for that purpose there is a functionality in this particular QGIS, that is known as no data. Okay, there is a function known as fill no data cells. So first of all we will select all the raster, like raster protected. Okay, fill values is 0. Okay, that means in this particular raster where there is a no data value, it will be converted that no data into 0. And here also we will provide high compression. Okay, and then we will provide the save to file. I think this is the raster protected, so we will provide save to file, raster protected, filled, save, run. Now initially this raster value is only single value, that is 1. Now it has two values, 1 and 0, where 0 denotes that this is not a protected region, and 1 denote that this is a protected region. Okay, now without closing I'm just going to do the parameter and to change this protected region to the roads, and everything remain as it is. Now in the raster protected we will provide ROADS. Uh, Similarly, we will do this for water area, water area, and similarly for water line. Now we can see that all the layers of field with a filled no data has been created. That means protected roads, water area, and water line. Now we can see that there is two raster of water. We need to convert that into one because we need to apply a single function on the water. So what we'll do, we will add these two layers. For that purpose, we will going to use the raster calculator. You can search for raster calculator. So there is a function known as raster calculator. It is used to apply the mathematical functions over raster. So we are going to take two input layers. One is the raster water line field and raster water area field. And the expression that we need to just do the addition of this two layer. So what we'll do, just click on this first raster, click plus, and the second raster. And we are going to save this function or the same this data set as raster water merge. Raster water merged. Now we receive the raster where there are three values, that means 0, 1, and 2, but we will only be required where the pixel is 1 and 2 as 1. So what we'll do, we will again go to the raster calculator and apply a function. I'm just going to select this raster water merge and applied a function raster value merge is greater than 0. So what it will do, it will convert this raster which has a three value, that is 0, 1, and 2, into a raster which has only two values, that means 0 and 1. uh, Means where the values is greater than 0 will be converted it's 1, and where the values are 0 will be treated as it is. And we just need to save this to a permanent file as raster value raster water filled. Okay, so now this is our four layer. I'll just move to the upwards raster water filled. Then we have raster road field. Then we have raster predictive field. We don't need water line, water area, and other. Okay. Now, next thing that we have layer representing the road and water pixels, and we can generate the proximity layers. These are also known as Euclidean distance, where each pixels in the output rasters represent the distance to the nearest pixel in the input raster. And this resulting raster can be then used to determine the suitable areas which are within the certain distance from the input. Search for and locate the area which are nearby to that. And for that purpose, we are going to use a tool known as proximity tool. Proximity. So in the search toolbar under the JIDAL raster analysis, you will find a tool proximity raster. Okay, in order to understand what this particular tool do, you can always go to the help and search for that. So what we will select, first of all, we will select any of the raster, like raster roads filled. Okay. Then we will going to select the georeference coordinates, because the input layer is in our projected. Then the maximum distance to be generated. So in this case, we are going to identify 5,000, because 5,000 in meters, that means 5 kilometers. Because in our initial, we can take 2,000 also. The output of this raster will be resulting as that for all the pixels that are more than maximum distance away, we will be set for the 5,000. So maximum distance to be generated at 5,000, and after the maximum distance, it will create a value of 5,000. Okay. Then again, we will apply, uh, in additional parameter, we will apply a high compression profile, and then we will save this data set as road proximity. Save, and let's run. It may take some amount of time depending on the area, because it is a very computationally intensive algorithm that needs to compute the distance for each pixel of the input raster. So this thing has been completed. Let's just explore what is this output suggest. So I'll just click on zoom to layer. So now you can see that this doesn't look quite good. So what we'll do, we will go to the layer styling panel and search for this particular single band. Maximum is 5,000. And if I just zoom into a certain area, whatever I'll do, I'll just open the road layer, so that we can connect our output that is going in a correct direction or not. Roads UTM. I'll just drag to this uppermost part. Okay. So now if you zoom to a certain extent, you will find that the pixels which are near to the road are black, and which is the farther to the road are brown. If I just click on this road proximity and click on this identify button, if I click over there, the value is 1816. That means this particular pixel located in the distance of 1816 meters from this particular line. Okay. So like in this case, if I'll just open the boundary of state. Okay. So these are the region which are located far, and if I just click over here, the value is 234. That means this pixel is located approximately 234 meters away from the road. If I just click in nearby to the road, the value is 20, because here the pixel size of our data set is 20. So now we need to do the similar exercise for the other layers. So I'll just go to the, close this, go to the processing toolbox proximity, and this time I'm going to select raster water filled, and georeference coordinate here 5,000. Here also we will provide 5,000. Then profile high compression, then output path will be water proximity. Save, run. So now it has been generated. Let's just drag this water proximity tool and this road proximity tool. So this is a water proximity and this is the road proximity. Okay. Now we will create a category raster in which we will define certain scores. And for that purpose, we will going to use the raster calculator again. If we go to the recent tool, raster calculator, and we will select first of all roads proximity. Okay, and we will apply a function. Just make this more bigger. Okay, so we will going to define three scores, that is 100 into bracket open and close road proximity is less than or equal to 1000. That means gives 1000 marks to all those pixels which is less than 100 or the 1000 meters from the road. In the same raster, we will apply another condition plus 50 marks to the roads which is greater than 1000 and which is less than or equal to 2000. And lastly, 10 marks or the 10 score to the pixel where the approximity raster has a more than 2000 of values. Okay, you need to understand this, that why we are applying this, because in your condition the score might be different. Okay, like we were going to talk about for the water body. So in this case we are clearly assuming that if the values are near to the road or the distance of the near to the road is very less, then give the highest marks, otherwise give the lowest marks. I'll just going to first of all copy this so that it can be further utilized. After that, we will provide the output as road reclass. Save, run. I think there might be some error in providing this. So I think we forgot this star marks again. 50 into 10 into, and let's run this again. So now it has been created successfully, and you can see now there is a raster which has a value from 0 or 10 to 100. Let's just go to the layer styling panel. Okay, and see that single band pseudo color. So though it's actually suggesting 5, but in actual it may only have only three values, that means 10, 50 and 100. So 100 is the value, 100 is the score that we have provided which is nearby to the road, 50 is not very nearby, and 10 is the far away. And the criteria we use is a 1000 kilometer, 2000 kilometer. Okay, now similarly we are going to use this function uh, in the water proximity, and in the water proximity we will apply this formula into the reverse manner. Like we want to give the highest marks which is far away from the water body, that means greater than 2000. We will provide 50 marks which is like greater than 1000 and between 1000 to 2000, and 10 marks which is less than 2000. Okay, or less than 1000. That means farther the better. So I'll just click OK and save this file as water reclass. Run. Okay, so we need just to change this also to the road proximity. Now it is water proximity. Let's just hit run once again. Still there is an error. Okay, error of inverted comma. So we have to make sure that all the functionalities of the formula should be written applied in a proper manner. Okay, water proximity is greater than 200, greater than 1000, less than 2000, and let's just see. And yes, it has run successfully. Close. Similarly, we receive the raster of water class also. Now we need to now we get the all the associated raster. That means the final data for the overlay analysis. Now we need to recall our determining the suitability that close to the rows and away from the water and not into the protected zone. So what we will do again, we will open the raster calculator. Okay, and we are going to use these three classes. That means water reclass, road reclass, and protected raster field. Okay, now we will provide an expression that is first, either you can provide the weightage. I'll just I'm just clicking this two button. Road raster plus water raster divided by 2. So this particular function give the equal weightage to both of the substance, but you can convert this by multiply by zero point 0.4 or multiply by zero point 0.6 as per your desire. But currently we are going to give the equal weightage, and it should not be in the protected zone. So for that purpose we will use multiply by sign, then raster protected field, and not equal to 1, because here the 1 pixel is that where the the protected zone was there. So we will apply this formula. That means raster road reclass plus water reclass divided by 2 multiply by raster protected, which is not equal to 1. Click OK, and we will give to the path the name is as overlay. We click save and click run. Now we receive a raster of overlay in which we have certain number of class marks from 0 to 100. Now we will need to clip this. For that we use clip raster by mask layer overlay, and the mask layer here will be the Goa boundary UTM. And here also you can apply in the advanced function as advanced parameter as high compression, and we will provide the path as overlay clipped. Save, run. Close. Now this is our final map which we want to create. I'll just click on zoom to layer, and we'll just provide a proper layer styling. I'll just click on layer styling panel, and we will select as single band pseudo color. And in the single band pseudo color, we can select as interpolation discrete and color ramp as per your desire. Like I think spectral will be the okay. Okay. Now you can see that we have five classes. The orange will be the is the I'm not just taking. Okay, I think. Okay, now we can see that the orange is the area which get 20 marks, and the dark blue which gets more than 80 marks. So this dark blue portion is the most suitable. So this is the we can define the categories. For example, this is not suitable. You can check. Then we can give least suitable, suitable, moderately suitable, and the most suitable. And this is our final map, which we found that these two regions is the most suitable as per our scoring method, and this region, that this particular regions are the moderately suitable, and this particular region are not suitable. So this kind of ranking map can be prepared only with the raster analysis of using the multi-criteria over the analysis. So this methodology can be applied not only for this specific purpose, but for any specific purpose. What you need to do is just to gather the right amount of data set and the right criteria, because the criteria is the there is no thumb rule for any kind of infrastructure criteria for any kind of infrastructure. So if you're a stakeholder, you need to decide for that. So thank you for this session. If you have any doubt, you can ask anytime. Thank you.